Hello everyone. Hello everyone. Today in this lesson we are going to discuss the bond parameters. So you already studied how the reactions takes place in an organic chemistry. The reactants, it may be attacking reagent and the substance, they interact with each other to form the intermediates. In turn, those intermediate will going to give the product. This is the way the reaction takes place in organic chemistry. But when the product is formed, that is affected by many bond characters like bond length, bond angle, bond energy. Similarly, when you consider the reactants or the attacking species, their molecules having different bond length, bond angle, bond energy also going to affect the formation of the product, the mechanism, the path in which the reactants are getting converted into product, the velocity or the rate of the reaction is also affected by these bond parameters: bond length, bond angle, bond energy. So these are the things to discuss in this lesson: bond length, bond angle, bond energy. Bond energy is also called as bond dissociation energy. All these three we are going to call it as characteristics of a molecule in organic chemistry. Bond length, as the name indicates, it's a length between the average distance between the two nuclei that is generally expressed in angstrom unit or picometer. The bond length is longer than single bond length is longer than a double bond length or a triple bond. The double bond length is longer than the triple bond length. Bond length are determined experimentally by using the X-ray diffraction or molecular spectroscopy. So I already told you that if your reactant molecule it's a saturated compound or unsaturated compound, they undergo different type of reaction. Why they undergo a different types of reaction? That is because they are going to have different bond length. The bond length is nothing but the average distance between the two nuclei. So they are going to overlap with each other. They are going to form a bond in that particular molecule F2. The bond length between the two fluorine atom, we are going to take the average distance. We are going to consider the distance between the nucleus and the outermost shell of individual atom, and we are going to divide that. We are going to add and we are going to divide by that 2. That we are going to call it as the bond length. So bond length varies from single bond, double bond and the triple bond. Its values will keep on varying. So carbon-carbon single bond means 154 picometer, carbon-carbon double bond 134 picometer, carbon-carbon triple bond 120 picometer, fluorine-fluorine 144, oxygen 121, nitrogen 110. Usually triple bonds are considered to be the strongest bonds. The bond length of the homonuclear diatom molecules are twice as that of the covalent radii. The second parameter generally we come across in an organic molecule is bond angle. This is the one which is going to decide the shape of the molecule or geometry of the molecule. The angle formed between the two imaginary lines drawn from the nucleus of the central atom to the nuclei of the two other atoms bonded to it. The internal angle between the orbitals containing electron pairs in the valence shell of a central atom in a molecule, that we are going to call it as a angle. So this depends upon whether your molecule going to contain a lone pair or a bond pair of electrons on the central metal atom, a central atom. The electronegativity of the central atom and hybridization. These are the three parameters which going to decide the bond angle, in turn decide shape or geometry of the molecule. If the bond angle is 180 degree, hybridization is sp, the molecule is linear. If the bond angle is 120, sp2 hybridization, the shape or the geometry is triangular. 109 degree 28 minutes or 0.5 degree sp3 tetrahedral. Some molecules they may also have 90 degree and 120. These are called as trigonal bipyramidal. sp3d hybridization. 90 degree means octahedral. So generally S character increases the hybrid bond and the bond angle increases. So as the S character increases, bond angle also increases. So for example, when you consider the methane, it going to have a shape pyramidal, because it going to have one pair of lone pair of electrons are there, therefore it going to have 107. So if you have a bonded pair and a lone pair, that also going to affect the bond angle. So if all of them are bonded pair, then you are going to have sp3 hybridization as in the case of methane. But whereas in the case of ammonia, you are going to have one lone pair of electron. Therefore, the bond angle has been decreased from 109 degree to 107 degrees. Similarly, when you consider water, it's going to have an angular, it's going to have two lone pair of electron. Therefore, you are going to have a bend shape or irregular shape. You are going to have an inverted V shape. You have to have. Bond energy. The third parameter that we are going to consider in case of the molecules is bond energy. It's also called as bond dissociation energy. Energy required to dissociate that particular bond. The energy required to break 1 mole of the bond in a gaseous state, that we are going to call it as a bond energy. Bond energy play a very important role because those are the ones which going to tell us how much of energy, what is the condition required for a particular reaction, what is the temperature I have to give, what is the pressure, what are the conditions. Thereby I can break down that particular that particular covalent bond, that is decided by bond energies. Higher the bond energy, we have to spend lot of energy to break that particular bond. Triple bonds are stronger than double bonds, in which in turn stronger than single bonds. CC bond is 347, whereas carbon-carbon double bond is 657, triple bond is 908, fluorine single bond is 155, oxygen-oxygen double bond is 495, nitrogen triple bond is 441. As the higher the energy, stronger the bond, so that we have to spend more amount of energy in order to particular bond. Strength of the sigma bond is more than pi bond. The resonance in a molecule affect the bond energy. Bond energy decreases down the group in case of similar molecules. Bond energy increases in the order sp, sp, sp2, sp3. Bond energy decreases with the increase in the number of lone pair of electron. If there is no lone pair, bond energy decrease, it increases in the order. N one lone pair of oxygen, OO two lone pair of oxygen. So molecule, bond energy and the bond length. CC single bond, bond energy is 347, bond length is 154. Double bond, carbon-carbon double bond energy is 657, bond length is 134. CC triple bond 908 kilojoules per mole, bond length is 120. Similarly, fluorine, oxygen and nitrogen. So as the bond length increases, this slide I have given in order to compare. As the bond length increases, bond energy decreases. Single bond is the longest and triple bond is the shortest. Single bond is the weakest and the triple bond is the strongest. Thank you. All the best.